Okay, 148, polynomials. Expressions like x, negative 7, 4y squared, and negative 24a cubed b squared are called monomials. Okay? Remember in social studies, maybe you do, maybe you don't, maybe you talked about monotheism and polytheism. Monotheism was what? Do you remember? The belief in one God. Polytheism was the belief in or many, right? More than one. So when they give us expressions like this and they say x, have you seen x before? Just x. Sure you have. We called it what? We call it a variable. Right? When you saw x, you call it a variable. Negative 7. Have you seen negative 7 before? Yeah, we called that a what? An integer. All right? 4y squared, okay, is also considered, these are all monomials. Yeah, these are all monomials. X, negative 7, 4y squared, negative 24, a to the third, b to the b squared. Okay. These are all considered monomials. When we think about polynomials would be when? When we take the monomials and we put them together. One God makes monotheism. Many or more than one makes polytheism. One of these terms, okay, is a monomial. Put them all together where you have more than one of them, and it's a polynomial. Okay? The degree of a monomial is the sum of the exponents of its variable. So follow along with me in that chart on 148. For the monomial x, what's the variable? It is a variable, so the variable is x. First one in the gray, we're going across. If there is no exponent listed, what is the exponent? How many x's do you see? 1. So it's all, that's the same as saying x to the first power. Okay, so there's that x. So if the degree is the sum of the exponents of its variables, if there's only one exponent and it's 1, what's the degree? 1. Negative 7. What's the variable in negative 7? There is none. Therefore, it has no exponent. Therefore, it has no degree. Now, keep in mind, it's the exponent of the variable, not the exponent of the integer. The exponent of the variable. 4y squared is our monomial. What's the variable? Y. What's the exponent with y? 2. So, are there any other exponents that I'm going to be adding together that come from a variable? So the degree would be 2. And then finally, this big one, variable a and b, the exponent with a is 3, plus the exponent with b is 2, gives us a degree of 5. Okay, Any questions about the degrees? We'll get to more of that, don't worry. Now they go on to say expressions like 8x plus y, 3x squared plus 2x plus 4, 5 minus 3y plus 5xy squared. These are all examples of polynomials. Because what monomials make up this polynomial? What are your monomials? Yes? 8x and y. Two monomials jammed together, put in the same sentence, is going to give us the polynomial. What we have here is monomials. 3x squared. I also have a positive 2x and a positive 4. The ones we had here were a 8x and a positive y. Yes? Oh, happy birthday. I'm going to say no to the treat, though. Thank you. 5. Next monomial. And a... Okay, so when they're all put together, we call these polynomials. So to make a little bit more sense now, you know what they are. Example 1, bottom of the page. Is 5x squared plus 2y a polynomial? Yeah, sure it is. Is 3 over x plus y a polynomial? There are exceptions. 3 over x is not considered to be a monomial. Up top, it tells us, okay, expressions like 3 over x, 2y squared over m squared are not monomials, okay? They are not considered monomials. What operation do we see in a lot of these? Multiplication. Once you start throwing division in there, no longer a monomial. Okay? And then 3. 3x squared plus 2x plus 4, definitely, again, polynomial. Okay? Top of page 149. We are going to state the degree of these polynomials. At the top, this is really important. To find the degree of a polynomial, first find the degree of each term. The degree of the polynomial is the same as that of the term of the greatest degree. So let's put that into practice. Okay? Now remember, the degree of the monomial is the sum of the exponents of its variables. So for this first one, 5x squared, what is my variable? X, and then x is to what exponent? 2. Are there any other variables there that I'm going to add those together with the exponents? No, so that one's a 2. How about here? What's the exponent with this 2x? Right, because how many x's are there? They don't put the 1 because they've already got one there. And what's the degree here of the 3? 0. So what is the degree of that particular polynomial? No. Why 2? Kate, read that top paragraph. Tell me why it's not 3. What is it? And why? Mark says 2. Why is it 2, not 3? Read it out loud. Yes. Which is the greatest one? 2, therefore our degree is 2. We're not adding them together. It's the same as the degree of the biggest one. because we add them within each monomial. We add them within each of these, okay? But we don't add them all together. Okay, so the degree here, 2 for the x, what for the y? 1 and 1 for the z give us a total of 4. How about here? 1 and 1 and 1, 3, and here is 3. Therefore, I take the greatest one. What degree was our greatest one? 4. Huh? How many x's? 2. How many y's? How many z's? 2 plus 1 plus 1, 4. That monomial is to the 4th degree. All right. Now, the terms of a polynomial are usually arranged so that the powers of one variable are either ascending or descending. Ascending would be going up, so you'd be going from least to greatest. Descending means you'd be going from greatest to least. Okay, so take a look at the ascending order. You've got 4 minus 6a plus 2a squared plus 3a to the 3rd. So they go from it goes in ascending order, because what's the degree of the 4? Is there a variable here? It goes from 0 to 1 to 2. Descending would go the other way. 3, 2, 1, 0. But it's also important to note that that 6a, it's a negative 6a. If there's a negative in front of it anywhere, when you move it, that's what's got to be in front of it. All right, so 149, exploratory. Let's do some of these together. Numbers 1 through 9. State whether each expression is a polynomial. Number 1, that look like a polynomial, yes or no? Yes. How about 2? How about 3? Well, that's a trick. Yeah, monomials can also be considered polynomials, but that's okay. 4. No, because of the right. 5. Good. 6. Yes. 12. Or excuse me, 7. Yes. 8. 9. Good. Here, let's try 10 through 18. It says identify each as a monomial, binomial, or trinomial. Well, a binomial would be how many? 2, and a trinomial would be 3. Well, let's take a look. Number 10 is just a monomial because 3x is just one of those terms. How about number 11, Raven? 4x squared and 3y squared z. Binomial because there's 2 of them there. How about number 12? Monomial. 13. Trinomial. 14. Monomial. 15. Binomial. 16. Trinomial. 17 and 18. Good. State the degree of each monomial. Number 19, 100x. Remember, the degree is the sum of the exponents with the variables. So 1. How about 20? 0. 21. 3. 22. 2, because, right. X is your only variable, therefore x squared is the only one you can count. Number 23. 3. Because 2 x's and 1 y give you 3. 24. 25. 26. 27. Yes, 7. 27. 5. All right, good. Now 28 through 36 state the degree of each polynomial. Remember, you're going to go with the greatest one. So 28. Well, we will be doing it for homework. It's just 1, right? Because 12s is 1 and 21t is 1. They're the same, so we just use 1. How about 29 is easy. How about 30? 1. How about 31? 4. We'll now add them together. Now with the polynomials, if there's that plus sign in between, they stay separate. 32. 5. 33. 34.
It's 3.
3 because of the 17r squared t.
Yeah.
35. 29. Sure. And 7 for 36. Let's try. I'm not worried about 1 through 16. I think we can handle those. But let's do a couple of the ascending and descending order ones. 17 through 30 say arrange the terms in each polynomial so that the powers of x are in ascending order. Try number 21. All right. So which of these monomials gives me my smallest degree of x? Raven. So we're going to start off with the negative 20. Very good. That one's gone. Then, Kate, negative 6x because that's just x to the first. Followed by Marlia. And then, finally, Mark. Good. Okay, try 25. Do number 25. What is, who's got the directions?
I do.
Yes. Powers of x are in ascending order. Power of x here is 2. Power of x here is... Power of x here is... There is no x. Powers of x, not a. So our smallest one, a to the third, followed by... Good, because x has a degree of 0, because there is no x. 1, 2. So there are no ties. Okay. All right, so descending, so greatest to least, I've got a degree of 2 and 0, and so my biggest one, and then plus. Very good. So maybe the fresh start's going to be, all right. 2 through 44 even. Let's just do number 2, because let's revisit that. State the degree of each polynomial. Remember this one. This is where we take the greatest degree, and that's going to be the greatest degree of the monomial, and that's going to be the degree of our polynomial. So for number 2, 5r is a degree of 1. 3s, degree of 1. 7t, degree of 1. Are there any of them greater than 1? So what's the degree? 1. If we don't add these together, you only add them within each monomial. So look at 4. You've got n and a p squared. What's the greater? Which is 2, therefore your degree, 2. Yes? So 12 x to the 4th, y to the 5th gives you a degree of 9. And then x, y to the 6th gives you a degree of 7. Because x is 1, y is 6. Right? So which one is greater? 9. So the degree is 9. Okay?